question, all path from source to target. I've previously done this question through DFS, and this time I'm gonna try to solve it using BFS, and we're gonna use Q. So let's read the question. Given a directed acyclic graph, directed acyclic graph means it has directions, but there's no cycles of n nodes labeled from 0 to n minus 1. Find all possible paths from node 0 to node n minus 1 and return them in any order. The graph is given as follows. Graph I is a list of all nodes you can visit from node I. There is a directed edge from node I to node graph ij. So let's look at example 1. This is our graph, and the graph input is like 0's index points to 1 and 2, and then 1 index points to 3, and then 2 index points to 3, and then 3 doesn't point to anything. And this is our output, so we can go from 0, 1, 3, or 0, 2, 3. And let's look at this one. This is our graph, and the output could be 0 directly to 4, 0, 3, 4, 0, 1, 3, 4, 0, 1, 2, 3, 4, and 0, 1, 2. Yeah, I think that covers everything. 1, 2, 3, 4, 5, and 0, 1, 4 from here. And let's start writing the code. So since we're gonna be using Q, I'm gonna make use of the collections module DQ. So from collections import DQ. DQ is a double-ended queue where we can pop it from the left or right. So pop left is gonna pop it from the left, which is what we need, and pop is just gonna pop it from the right. So first, let's do some initial things. So we can define our end node. End node is gonna be the length of graph minus 1. And then we can have our Q equals DQ. And then Q, we can initialize our Q by appending the node 0. And then we can have a result list for our final result. Let's start writing the BFS. So BFS will start with while Q, and initially our Q has the initial node 0. So while Q, we can do something called current path equals Q dot pop left, and our node will be our current path's most right one. So let's say like 0 points to 1. Let's say our current path is like 0, 0, and the 1, and then node, we want our node to be the last one in the list, so that's why it's negative 1. And after we get our node, let's do something like for neighbor and graph node, and then if node equals the end node, then we can do result dot append our path, which is we can do a temp path equals current path dot copy, and then we can do temp path dot append neighbor, which makes our path current. And then if the neighbor node equals the end node, then we can directly append our temp path to our result. And then else we can Q dot append temp path. And in the end, we just have to return our result. So basically, why are we current path and then node? Usually we just pop the node, right? But this time, because we're traversing the graph through a path, and Q is always updating like the temp path with all the neighbors. So let's say like we start with node 0, and node 0 points to 1 and 2. So the first one that's popped will be 0, right? Current path would be 0, and then node would be 0 because node is the last element of current path. And then for neighbor and graph node, which is in node 0's neighbor, we have 1 and 2, right? So then temp path will be like 0 and then 1, and then the other temp path will be 0 and 2, right? So for neighbor, if neighbor equals end node and none of 1 or 2 equals our end node, which is 3, we want to do this, but because none of them equal 3, q dot append temp path. So now in our queue we have 0, 1, and 0, 2. And then we go to the next one. So currently our queue has 0, 1, and 0, 2. And we want to pop left, so 0, 1 will come first. And then node will equal 1 this time. And for neighbor and 1, we have 3, right? So temp path will have, now temp path will be appending 0, 1, 3. And then if neighbor equals end node, because now it's 3, we want to append the 0, 1, 3 to our result, which is the first one here. And then it goes back to 0, 2, and then 2's neighbor is also 3, so it's going to be 0, 2, 3, and in the end it's going to equal the end node again, so it's going to be appended to our results again, which is why this one works. So please let me know if you have any questions, and I love to answer them. Thank you so much for watching.